Hello everyone, welcome back to my Edison Blue Amberol record player project. Right, the way I left it was this video where I showed you it just playing, and I'll tell you what, just get me big hand, my new pointer. I've done a big pointer. Yeah, here we go, look, yeah, there we go. So, let's turn it round. There we go. So you can see all this down here, all this solderless breadboard that I have used to control it and get the sound. And now I want to make all this into a PCB. And I get my PCBs from PCBWay. It's my only choice, it's what I've used, I've had no problem, there's no reason to change. So yeah, so that's this video is just to sort of roughly show you the process that I go through to convert this breadboard into a PCB, and there are several choices. You can get it, well actually yes, there's several choices. You can just get the PCB, and let's have a look at the PCB, shall we? Oh, and also I'm going to keep pausing and then coming back and pausing when I get things set up, so just give me a moment. Yeah, here we are. This is the PCB I've already had made, and I'm going to show you how I get these, how I design them and make them. Let's see if I can get a better focus on there. My light is not pretty good, not very good, but I'll do my best. You can see they're excellent. I mean, I can't fault these PCBs. I mean, the silk screening is brilliant. I reduce my, I mean, I don't know if you can see. Let me see if I can get it closer. Not doing too well there, but yeah, so you can see the component marks. I try to get them as small as I can, because sometimes you get them right close together, and the silk screen comes out really well. I mean, the default is more like where it says speaker, that's more the default size, but I found that they do a really good job at the silk screen for the marks that I make reduce. So I'm going to come back to this. I just wanted to show you it off. I mean, even my logo comes out really nice at that sort of size. Yeah, this is for a big. It's optional. Is this capacitor in here? But I've put two connections for it down there. Yeah, so let's have a look and see how I get to making one of these PCBs. Right, you can see here that I've actually put all the components, and I've used a standard off-the-shelf sort of components here, and placed them on a breadboard. So the first thing I do is I make a copy of that breadboard on my computer, and to do that, the best thing I find for making a detailed circuit of the breadboard is Fritzing. So I will just bring Fritzing up. Alright, here's Fritzing, and you can see that I've got my breadboard. I started off laying it out exactly as I've got all my wires and everything, but sometimes you can find that you can't find components that match exactly what you've used, and some of these, like this one here, hang on, let me get my big hand. Yeah, some like this one here and this one here and this here. Oh, even the speaker actually. The motor's fine. Well, that motor doesn't represent the motor that I've used, like, but it's a motor. But these are Adafruit, and so these come from the Adafruit. Do a really good. Hang on, let's try and find Adafruit on here. Where's Adafruit? What's that one there? Yeah, there's Adafruit. You see, Adafruit do a nice library of their modules that they use for fritzing. So if you have if you're using Adafruit stuff, you can use their library and you usually find their modules. But I get a lot of my stuff off the internet and eBay, which from the Chinese, cheap Chinese suppliers. And so I haven't used these. What I've used is the cheap ones. And quite frankly, I couldn't find the components that match exactly. But for those components, well, sometimes when I can't find a component, I will make a component. Fritzing has a very good editor for actually making components. And like this is for the ST. Well, you can see that it's got my web address there. That's one I've made. I made this one as well. I made this. Actually that one there, and I've made that. And obviously I've had to make that motor as well. This was the motor that I had. But sometimes I'll make the components and I will, so that they can fit into the breadboard just as I have them on my bench. And that's the way I do it to start with. But this time I just couldn't be asked to make that one, and I couldn't be asked to make that one either, and I couldn't be asked to make the stylus either. I've just used the microphone as a stylus, and this was close enough as this one, so I've used this one. And the speaker, well, a speaker's a speaker. So that's how I start off, and then what I do is I will place them all in Fritzing just as I got it on the bench, so then we know it's an exact copy of what I've got on my breadboard. And then I'll go to my schematic. Now I've wired all this up, but I'll tell you what I'll do is I'll just delete a load of these wires there. So what you get is something like this. There we go. Yeah, something like this with the rat's nest on the drawing. You connect everything up here, and then it will automatically create the rat's nest where you need to connect everything together in the schematic side. So let's just undo that. Just put it all back where it was. There we go. And then I draw that, and this is the schematic I work off to make my schematic in KiCAD. So what we'll do is, once we've done it, we could use the PCB. I tell you, I used to use the PCB thing when I used to make my own PCBs, when it was all through hole and big tracks and everything. I used to make it here in Fritzing, and then I would just do it on my plotter and engraver and what have you, and make my own PCB. But now, of course, I've gone semi-pro with my PCBs. No, I haven't gone pro. I've gone amateur with my PCBs, and PCBWay do a really good price. And making my own PCBs and getting PCBs from PCBWay are a completely different kettle of fish. When putting components on a professionally made PCB, you can't beat it. Everything just flows together. Whereas my homemade PCBs, well, solder went everywhere basically. So anyways, that was that stage. So I'll just get Fritzing. I meant to say I'll just get KiCAD. Here it is. This is the schematic part. So basically all I do is just copy what I've got here, apart from where we've got modules. Now sometimes I will use a module, in which case, so like let's take the OLED display. This is going to be a bought item. I'm going to leave it as a bought item, and it just has 4 pins to plug in. So if we look at where I've put my OLED display, it'll be somewhere near the microcontroller. Is it? That's the driver. Right. Oh yeah, here. You see, all that on here it's going to represent is 4 pins, because I'm using a module that plugs into a header with 4 pins. But also what I can do is, if we KiCAD, I can actually make my own components again, and we can make our own footprints. At the moment this is just the symbol for it, because we're in the schematic mode and we're looking at the schematic. But if we look at the properties of this, we can see that we've got a footprint, and I have made Tim's OLED I2C, and we can look at that. And what I do is, when I make for this particular, the actual footprint is going to look like this. It's going to show where the screen is going to actually sit on the PC. Oh, well, not on the PC, but over the PC. PCB. You'll see it later on. But it just has the main header there, and we need a silk screen so that we know where the screen is going to sit. Okay. So that's another thing that KiCAD could do, and I like to do. So what we do is, that one there will just stay as a 4-pin header, but whereas I have here my microcontroller, this is actually represents the module. So if we look at the board, it's representing this module, but on this board there may be some LEDs, some capacitors. If I was going to run it at 3.3 volts from a 5 volt supply, there may be on the back of this there's actually a linear regulator, but I'm just using a chip, and this chip uses very minimal external components, which we can see here. So this actually represents the actual chip itself. So if we go and look at the footprint for this, we can see it's just the actual chip, and we can actually get a 3D view, and there it is. That's all it is. So I'm not using a module here, I'm just using the chip, because now that I'm getting it made out, I can tell you these little pins, I'll talk about these pins, they're so small and close together, and I'll show you what I do when I come to soldering them. So anyways, yes, so other components, and so like we have here, we should really be looking at the schematic. Let's go back to the schematic. So here we have this is the one that I've made. We just show the pins in and out, because on this breadboard I'm actually just using the module, but this module has components in. So if we look at that module, which is it that one? Yes, it's this one here. So you can't see it here, but what I will do is I will bring, what I tend to do when I get components like this, and I know I'm going to make, there's a few more resistors and an IC on this board, but I haven't drawn them here. What I tend to do is when I get modules from China, I tend to reverse engineer them. And so what I will do, sorry about my chair. What I tend to do is reverse engineer them. So if I open up another instance of KiCAD, just one moment. Yeah, what I tend to do is I reverse engineer them. So this is the actual circuit for this component here, because when I'm getting the PCBs made from PCBWay, what I will do is I won't put 4 pins for one of these modules to go on. What I will do is actually design the PCB to put all the components on, because well, we can. So yeah, so what this is, what the components that are actually on this module. And if we look at, I do the schematic as well. So if we look at the I do the PCB layout as well. So you can see here that's what it looks like. But we can also get a 3D view. There we go. Oh, I haven't done the inductor coil. Never mind. I'll have to come back to that. I'm sure I had done that, but never mind. Oh, mind you, I've updated KiCAD. I probably have to move my libraries across. Anyways, so you can see I reverse engineer it. So because I've reverse engineered it, I now have this circuit here, and what I can do is I can copy that circuit into my circuit for well, there we go. So I can copy this circuit into my circuit for my record player, and so when we put the PCB, get the PCB made, we're not actually adding one of these components, one of these modules. We're actually adding the actual components for the voltage regulator. Oh, well, for this it's a boost, actually a boost. Yeah, it boosts up 5 volts. I want it to go 5 volts upwards. So yeah, so we've got that. That's how I do that. What is this? Yeah. And I do the same with this. So basically what we have done here, is that the one? Oh no, that's the driver that there. So yeah, so I do the same with the driver. What I do is I reverse engineer the components on this module, and then I can just put the components straight into KiCAD and just draw it the same and mark up the pins how I've used them. And I've also done the same for the amplifier. This is just a mono, I think AB amplifier. It's got like a push-pull thing with V1 and V2. One's a pull and one's a push, so you get a bit more noise out. Oh, hang on. Clicked in the wrong place. Yeah, so there's the amplifier, reverse engineer. Well, it's just one chip actually. A chip, a resistor and a capacitor. That's all it is. So I put that on there, and then you've got all the plugs, sockets and everything, and then we end up with the circuit diagram. So basically what I've done is I've copied it all from here, and where necessary for the modules I have broken the modules up into their individual components and added them to my circuit diagram. So we are making a PCB with all the components on. The only exception is the OLED display. These OLED displays have a ribbon on them, and I don't have anything to unsolder these ribbons, so I'm just leaving well alone, staying away from that ribbon soldering for the moment. Yeah, so I'll leave that as a plug-in thing, and it also enables you to attach it to fascia board, the OLED and what have you. So if we look at the PCB, let's make that bigger. Now then, I'll just give me one moment. Like I say, the first PCB is always a prototype. So if I just bring this into shot, let's see if I can get a focus on it again. You can see that I've added an option for an encoder switch here. This is not going to be fit. I'm not going to fit an encoder switch at this moment. A PCB has a lot of real estate on it, and there's no reason why you can't add options you think you might use at a later date. Although you don't need them on there, you can stick some on there. Like I say, the microcontroller here has got lots of pins on it, and I can use these to do other things. And I think to myself, what may I want to add to it, and what don't I want to add to it? I don't know. And sometimes, like with this, working on a solderless breadboard, you get bad connections and stuff. And so once you then move to a PCB, you can start soldering things to actual points. So basically, I can use this PCB as a prototyping board, as well as use it as a board to do the function that I've designed it for. We can use it as a prototyping board to add things as well. And so I tend to add things that I might want to use at a later date, like an encoder, and I've put of the pinouts. I've put the pinouts here into so I can solder wires easily to the pins of the microcontroller, and things like that. So I tend to add more than what's necessary. Now with this PCB, as it stands now, what I'm going to be using is I just put that somewhere. I'm going to be using one of these. I found a 1K one. I'm going to give this a try. One of these variable resistors, a potentiometer that we can adjust the speed with, and I had an idea after I had these made that if I'd stuck a hole in here, then this is where I could mount this. If I'd have stuck a hole through, I could have mounted this to the back of the PCB, and it would have held the knob in place. So what I've done is I've actually manually drilled one of these PCBs, which you can see here. If I just lift the screen up, I've actually drilled a hole through it, and let's just bring back what do you call it? There we go. So you can see that I've altered the PCB slightly and put a hole in here for. So you've got either a choice of using an encoder or a potentiometer. The options there. The price of the PCB is not going to change, but you have now two options. So this is something to bear in mind when designing a PCB. And we can have a look at this in what it's going to look like as well. I always like to look at the 3D view. Actually, what I've done is I've omitted the encoder and everything. So this is actually what the board is going to look like once we're finished. Half the stuff is not going to be on here because half of it is just for a later stage in development where I can use the board as a prototyping board, as well as it being functional. And you can see here there's the coil and everything for the boost. That's the boost part. This is the amplifier part here. and there's my microcontroller, and there's the motor driver. I haven't put the switch in there, I don't know why, but I've designed that to do a switch. But what I also did is because switches are hard to well, it's hard to find a switch that somebody else has used, is more the phrase. So finding the right switch, or you might have some slightly different switches. I've actually put a header here as well, so you can actually connect a switch with wires as well. So everything. So it's a good idea to do that. And before I move back to PCBWay as well, who's made my PCBs, I just want to show you why I use KiCAD. I use KiCAD because I can create a 3D model of this. So let me just show you. Alright, so here's my, I use FreeCAD, right good 3D program, but it uses the same engine that KiCAD does, which means it can create the same models for the same engine. And you can see here that I have, let's just highlight it all. Well, actually the PCB, there's that's the mount. Yeah, that's just the mount. My potentiometer, which it goes through it now. Alright, hang on, I've got it all stitched together. Right, that's the board. Alright, yeah, and there's all the parts. So all this, let's just highlight all that. All that was created in KiCAD, and I can import it, or I can actually just straightforward open it up in my modelling program. And this way I know that all these brackets and everything that I have made to fit are going to be correct, and I can actually see the model finished, and I know it's all going to go back together. There you can see where I'm going to put the potentiometer there. So this is all going to fit really well, and my OLED display there is going to be sat on standoffs. And that's another thing as well. You see, when I made the footprint, let me just see if I can just come back to them. Not that one, that. Right. Yeah, I want that open. Top, bottom. Oh yeah, I do want that open. Yeah. So, what do I want? Oh yeah, there we go. Yeah, so if I'll just make one of them visible. So what I've done when I make the PCB and I've made the footprint for this OLED display, not only did I make the footprint for this header to go in place, I also put the holes in the footprint to show where the holes line up with the front, and then I can place a standoff where it all fits together. So there's my switch as well. Look, and my knob. My knob's made in this program. I've made that knob from the same material that I've made the actual machine. I'll come to that eventually. So yes, that's one of the other reasons for using KiCAD. I can actually create a model and place it in my drawing model, so we can see it all fits together before we actually make it. Right, let's get back to KiCAD. Right, I'm back to KiCAD, and I want to just mention two plugins for KiCAD. Well, there's three plugins actually. There's this one, PCBWay Fabrication Tool, and there's this one here, PCBWay Plugin for KiCAD. And you might ask why we have two for PCBWay. I will explain the difference between the two in a moment. And I have this other one as well, this HTML bill of materials. I find this very useful. We will show that later on when I come to actually assembling my PCB. But it's these two plugins that I want to explain at this time. So if we, in KiCAD, if we go to our edit, no, is it edit? Or is it the main, actually the main program? Hang on, this is the main program. Oh, it's the control window. So in the controller window, we've got the plugins and contents manager. So if we go, we open this plugin manager, and we can see that I have, well, there's lots of plugins. You can make these nice curvy round tracks. I haven't tried that yet, but one day. But what I am going to do is I'm just going to filter this. Let's see. Oh, there we go, installed. So what I have is, there's one for Arduino modules as well. So if you're actually going to use Arduino modules, then you can use that. Let's just click on it. And it will create footprints for you to actually plug in, like your Arduino Nano or your Uno or other boards onto your board. They're already done for you. So, and that's me, interactive HTML bill of materials. You're better off going to the actual GitHub and downloading it from there, so you've got the latest update. So I want to talk about these two PCBWay plugins. This one makes things really easy for you to order a PCB from PCBWay. It's practically just one click and you're done. It can't be any easier than that. This other one, so once you start making PCBs at PCBWay, on PCBWay they have a shared projects page, and let me just go there. Here we are at my PCBWay projects. Now, once you start making PCBs, you may want to share your project with your PCB. Say, for example, we'll look at my Edison Blue Amberol record player, and here it is. I've made a nice shared project like I have on Instructables and everything, showing you what everything does. And when you make a project like this, and you write up your project, describing what it does and everything, there are certain things. Let me just sign in there. Right, so let's just go to edit project. When you come to make a project, you give it a title, a pitch, something to get people to come and look at it, and some nice pretty pictures. You can add a Gerber file, and you can add up a parts list. You can upload a Centroid file and other files, like this is the file. On this one there's there's firmware that's needed. So to create these files, we can do that with one click. So what we can do is, let me just exit out of here, and we'll come back to KiCAD. Here we are back at KiCAD. So this one is the one I was talking about, where you need files to upload to your shared project. And all you do is you just click it. That's it. And it's done. Here are the files that you need. You've got the bill of materials, you've got your Gerber files, you've got your net list, and you've got your positions list. So they're the files that you use in your shared project. All you do is you upload them to clicking on the individual buttons for each one, and that's done. That's all you need to share your project with PCBWay on your shared projects. Let's close that. Let's go to this other one here. I just need to set this up so I've got my Explorer as well. Right, yeah, so I've opened up my Explorer here because I want you to see what happens with just one click. So you've made your PCB, and you obviously do your checks. This is a good thing to do before you ever send anything. You just do run a check, and make sure you've got the green go. So you want 0 warnings and 0 errors. So you know your PCB is good before you do anything. So we'll close that. And then, so we want to order this PCB now, and I'm going to order it from PCBWay. So what do? I just click this button. There's a thing, and there we are. Why am I getting a message? Oh, accept all cookies, yeah. And that's it. It's done. If you want to change your options like colour, size or anything, you can do. The quantity is as default is 5, but if you want 10, I mean, like this for this, I just left it at 5. The only difference is, let me just come back to this. So we just did the one click on KiCAD. So let's just go full size with PCBWay. You can see that the PCB is there. You can, if you like, go down and choose a different colour. Some of the colours are more cost you more because they've got to change the VAT. But if you use a standard colour, it's not going to change the actual price. There is down here an option for an SMD stencil. If you can't make your own, then I recommend you get a stencil for the surface mount devices. It makes things a lot easier having a stencil. I can make my own, so I don't bother clicking these. And if you want them to get the parts for you as well, use the assemble. You can have them. Their assembly service to put all the parts on the PCB. I do believe that there may be options for whether you have just the surface mounted devices or the through hole devices as well. But basically this goes through an assessment, and they come back with the price and they talk to you, and then you can discuss exactly what you want to do and finalise the deal. But just for the PCB on its own, just as it is, we're done. All you do is choose the postage, and you can obviously you have to make an account and everything, but basically that's it. All the files were done, uploaded for you. Everything were done with the one click of that one button. And like I say, because I don't plan on making more than one record player, I've just left it at the 5. The only thing that changes, you can get 10 if you look at their advertisement. If you, let's see, can we go to main page? There, it says there. Look, $5 for 10 pieces, 1 or 2 layer. Okay, so it costs you the same for 10 pieces. I mean, if I ordered the extra 5, I don't know what I'd do with them anyways. So 5 is enough for me in this case. But if you did want the 10, you just go down to pieces, choose. Oh, before I do that, can just where's postage? Ship. Right, £3.70 there. Look, obviously, if you get 10 more pieces, the shipping is a little bit more. That the price of the PCB is the same. The shipping is a little bit more because obviously you've doubled the weight of the package. So the shipping will increase because the weight of your package has increased, but that is it. So the other thing is basically just leave it at 5, and you can see there it's just dropped it down a few. The price is negligible. Well, for 5 more PCBs, it doesn't really cost you that much more. It's just the postage that changes. Okay, so yes, I think I've rambled on now for over half an hour, about 40 minutes now. So what I'm going to do is I'm going to leave it here, and I will do a part. I'll split this into part 1, part 2. So I'll do a part 2. Well, you've seen that I've received the PCBs, and I'm going to put the PCBs together, and we're going to actually make up the PCB. So if you've made it this far, thanks for watching, and if you ever want a PCB making, go to PCBWay. I find them really helpful, and everything they'll do, and they'll bend over backwards for you basically. So yeah, and obviously you've got well, let's just go home. Yeah, you can also go to my shared projects and download my projects. I've done a few here. There's my controller. I did a little robot with eyes that moved. This is another motor controller. This is just a pi divider. This is another motor controller. It's been superseded by this one. This is my little mini pen plotter. A lot of people like that. I think there's 1,000 and odd people really like that. This is the DF player. One of my favourite channels is Learn Electronics. I think I've said that right. And they designed a nice little player. But I wanted stereo, and I've explained it in my thing. But basically, it takes this DF player and it adds another amplifier so that you can hear things in stereo from it. Yeah, okay. I'll leave it at that. Thanks for watching, guys.